All right, so far we've worked with one variable for bar graphs, for box plots, for dot plots, and histograms. And then we looked at two categorical variables. So now we're going to take a look at two quantitative variables. So when we've worked with data for bar graphs, box plots, dot plots, histograms, and that type of data, because we're looking at one variable, is called univariate data. Now, with our Vitruvian Man activity, we explored bivariant, bi meaning two, uni meaning one, bivariant data. When we compare those two different variables, we're exploring just the relationship between them. So when we're looking at two separate variables here, so remember with the Vitruvian Man, we looked at our height, and we looked at the arm span. And we wanted to see if there was a relationship between those two variables. So when we're graphing two quantitative variables, this is something that we've talked about in our first semester, and we used RStudio to help create these, and they were called scatterplots. So for two variables, when we're looking at two quantitative variables, just make sure they're quantitative variables, that scatterplot shows that relationship between two quantitative variables. Now, one dot represents the same individual. So we plotted 1 point for someone's height and arm span. The values for one variable appear on the horizontal axis and the other one, so the x-axis, and the other one goes on the y-axis. So we have two different variables that we're comparing. Each individual in the data set is going to appear as a point. So remember, this is each individual in the data appears as a point with both values belonging to that individual. So for example, if I'm looking at this Vitruvian Man activity, when you have the scatter plot here, looking at this guy, this is one singular person that had a height of, 57 inches. And we're also looking at our arm span. Actually, I said inches, but remember we measured this in centimeters, so we have a height of 157 centimeters, and then we had an arm span of that same person was 139 centimeters. So that describes one singular person's height and arm span. So when we're looking at identifying variables in this activity, we first have to put some names to the variables. So first, if we have our response variable, so we're going to have two different variables, the response variable and then the explanatory variable. The response variable measures the outcome of the survey or an observation that we may have or a study that we tried. When we're looking at an explanatory variable, the explanatory variable helps us explain, or it influences and changes the response variable. So when we're looking at our explanatory and our response variables, normally you often find the independent-dependent verbiage. The only thing is here in stats, we don't really use the independent-dependent verbiage with the variables because it kind of pertains to something else entirely. So we always use the explanatory and the response. But the idea behind it is that the response variable depends on the explanatory. So the response depends on the explanatory. Now, when we're looking at our explanatory variable, think of like it has an x in it. So it's always going to be our x variable. So explanatory is going to be our x, and then our response is going to be our y. So looking at our x variable is always going to be the explanatory. So if we're trying to see if one is going to explain or influence the change in the response, that variable is going to be on the x-axis. Our response is going to depend on what our explanatory was. Think of like that's the dependent variable, you can kind of say, with your response. So our y variable is always going to be our response variable. So when we're looking at our activity, the x variable is explanatory. Remember, think of x variable, explanatory. So when we're taking a look at our explanatory, it's always going to be the one on the x-axis. So here in our case is arm span. The y variable, so the one on the y-axis, is going to be the response, which will be your height. Now, interpreting the scatter plot is a whole nother thing in and of itself. So now that we know how to make the scatter plot, we're now going to be interpreting the scatter plot. So if in any graph that we have, we always want to see the overall pattern. And so when we're describing the pattern of scatter plots, we're going to use three things: direction, form, and strength of the relationship. And then we're going to maybe have some type of outlier it's just the value that falls outside of the normal pattern of our relationship between our explanatory and our response variable. Just like what we had with outlier, when we're looking at one variable, we're going to be taking a look at the overall pattern and see if it lies outside that pattern. So when we're looking at our scatter plots here, we're going to take a look at form, direction, and strength. So the form is just looking at the overall pattern of the data, seeing if it actually leads to a pattern or not. So when we're looking at pattern, usually it can follow some type of function, so like a linear or exponential function, or a logarithmic function, or when we're looking at maybe it doesn't follow a pattern and it's just random. So the next piece is direction. Direction is going to have the positive or the negative slope, meaning positive slope, when my x's increase, my y's increase as well. So we're basically going to be looking for the points increasing from left to right, or if they're decreasing left to right. If it's decreasing, that's our negative slope. They're decreasing left to right. If our x's increase, our y's are decreasing. And then we have our strength. Basically, how close do the points lie together? How close are they together? And we're going to take a look at different examples of those. So remember, looking at form, so this is the pattern. So we're looking for a pattern here to see if there's anywhere that it can follow the function. So the pattern, does it follow a function? Or is it just random? So if it's a linear function, think of the points are going to be following some type of line. So I'm going to have points that I can kind of look at my line through here and they form that straight line. Exponential is where they're going to slowly increase in our growth. So we're going to slowly grow. So we may have something that looks like this. Might be exponential, and it's going to look something like this when we draw lines through it. Or logarithmic. Logarithmic is kind of like this, where it grows really fast and then kind of levels out. So it's going to look something like this. When we try to fit a line to it or some type of pattern to it. So direction is basically how are my points going? Are they increasing left to right? Are they decreasing left to right? Where are we looking at and how are we looking? So when we're looking at our points here, so for positive, we're going to see as x increases, so as x goes up, our y also wants to go up. So if we're looking at some type of positive direction, we're going to make sure that our dots are increasing left to right, or something like this. Negative is that they are decreasing left to right, so something like this. Whereas our x increases, our y decreases. So as we get further into our x's, our y's are decreasing. Here, as we grow with our x's, our y's are also increasing. Okay, and then the last one is describing our strength. So looking at the strength of the relationship, there are 3 different types of strength. And remember, this is really just how close, so how well do the points fall in a line? So how well So there's a weak, a moderate, and a strong. So weak, meaning our points are going to be really spread out. There's really not going to be, you can kind of see that we're going to have a relationship. We're going to go ahead and just look at positive values, because when we're looking at positive direction, we're going to make sure that our points are going to be increasing left to right, but you can also have the negative direction where they're decreasing left to right, or as our explanatory increases, our response decreases. But we're just going to look at positive examples here. So positive direction only examples. So when I'm looking at positive examples, if I would have something that's weak, I would have something that like all my points are going to be super spread out, but I can still kind of tell that it's going to be positive. And how you can tell with the weak is that if you got not a lot of space around our points, you can kind of tell that's a weak relationship. Our points are really spread out. But as we get closer to a stronger relationship, our points are going to get closer and closer together. So like a moderate would be something like where we have the points are really close together, like something like this, where I can tell that it's actually really increasing and it's starting to get stronger. So we have all these different points here that are getting closer together. We're having more spaces on the outside of my points. And strong means they're going to be really, really close together. So we got something like this, where we have all of our points are going to be really close together, and I can tell that this is going to be a really strong relationship, where we got lots of room here and lots of room here. So they all fall in line here, and they're all really close to that line. So let's go ahead and try an example of actually creating a scatter plot. So we have, suppose we hypothesize that the number of doctor visits a person has can be explained. So that's important. Can be explained by the amount of cigarettes they smoke. So if we're trying to make sure that the amount of cigarettes they smoke explains the number of doctor visits, that means this is going to be my explanatory variable. Because I still got to figure out which one goes on the x and which one goes on the y. So remember, explanatory is x variable. And we're trying to figure out that it explains the fact that we're going to the doctor and having an increase in doctor visits. So we want to see if there's some type of relationship. Does it increase or does it decrease? We don't really know. And this is going to be the number of times that per year that they visit the doctor. So they asked 10 random people to get some following information. So we have X is going to be the number of cigarettes per week, because that's our explanatory. Our response is going to be the number of doctor visits per year, so that's our Y. So once again, our X is going to be the number of cigarettes per week, because we're trying to see, does this influence our Y, so our doctor visits per year. So does this, our X, influence our doctor visits per year? All right, so we're going to go ahead and make our scatter plot. So we're making our scatter plot. We need to make sure that we are going to make our x and our y-axis. So we have our y-axis here, and we'll have our x-axis down here. All right, and we'll have on our x the number of cigarettes per week, because that's going to be our x. Our y is going to be the number of doctor visits and this is per year. All right, so now we're going to start plotting these points, but we kind of got to figure out what we're going to go up by. So let's see. For our x, we got to start at 0. So we'll have 0 down here. And we got to go up to 60. So we can go up by tens if you wanted to. So we can go up 0. We got 10, 20, 30, 40, 50, and 60. And then we got for our number of doctor visits per year, our lowest is 0, highest is going to be 6. So we got 1, we can just go up to 6, 2, 3, 4, 5, 6. All right, and we're going to plot these points. Remember, each point is going to represent one singular person. So one person smoked 0 cigarettes per week and went to the doctor once. So 0 cigarettes per week, went to the doctor 1 time. There's our first point. Okay, one person smoked 3 cigarettes and went to the doctor twice. So 3 is probably right about, there's 5, 3 maybe right about here. And we have 3, 2, so it should be right about here. Alrighty, then we got 21, so 21 is maybe right about here, 4. Alright, and we got 15, 3. We got 35, 5, 1, 45, 40 and 5. Then we got 66. We got 0, 2, and 0, 0. Alrighty, so now it also says describe the relationship between the variables. So when we're looking at describing the relationship between the variables, we're always going to put it in context of the problem. Remember, we're going to address our 3 things. So we're going to address our form, we're going to address our direction, and we're going to address our strength. So looking at the strength of the relationship, notice how we can really see that these dots are close together. I would say this is probably a strong relationship, and it's pretty linear. And then we also have to figure out, is it positive or negative? So that goes with our direction. So we have our form, which is linear. We have our direction, which we say as we increase the number of cigarettes per week, our doctor's visits seem to be increasing as well per year. So we could say that's positive. And I would say there's a strong relationship here for our strength. So we can say that there is a strong, so that resembles our strength. We're going to have our direction, so positive. Linear relationship. And we're always going to say between what two variables? So between the number of cigarettes a person smokes a week. And we can also say the number of doctor visits per year. So make sure that you always put it in context of your description, So what are the two variables? The two variables are the number of cigarettes a person smokes a week and the number of doctor visits per year. Now, what's nice is that we have been using our TI-84s, and we can actually create a scatter plot that's going to look very similar on our graphing calculator. So here's how we're going to do that. First of all, turn it on. So we need to make sure that we turn on our calculators. Remember, hit that on button. That's in the bottom left. All right. Now, we got to get to our list again. So remember, you're going to hit our stat button to get to the list. And you're going to go to edit. Now, the only thing here now, we have not just one variable that we're looking at. We're looking at two variables. So we're actually going to have two lists being put in. You're going to put the x values into list 1, and you're going to put the y values in list 2. So I'm going to clear out this guy, because if we got something there, we're going to clear it out. We're going to hit enter, so we clear out that data. And I'm going to go back to my data here. And I'm going to put all my x values. So I got all of my cigarettes per week. So I got 0, 3, 21, 15, 30, 5, 40, 60, 0, 0. Remember, that's the 11th position, so I now got them all. I'm going to scroll over to L2, and I'm going to put all my y variables, or all my y values in. And make sure they correspond with your x. So we got 0, 1, 2, so we're going to keep the order the same. Okay? And these are all directions that are right here. So our list looks just like this. Perfect. All right. Next, we have to then change our plot. So remember, we're going to go to stat plot. So we're going to go to second, stat plot. You might have a histogram there because that's what we were looking at before. We're going to go ahead and enter. And we're going to scroll down to our scatter plot, which is that very first guy. We're going to hit enter. Notice here it says X list, L1, Y list, L2. Perfect. This is exactly what I want. If you wanted to, you could change the mark if you really wanted to. I'm just then going to hit graph. All right. Notice nothing's coming up. Remember, we always have to let the calculator adjust the window for us. So we're going to hit zoom, and you can either hit 9 for zoom stat, or you can scroll down to zoom stat, and it's going to automatically fit your screen for you. It looks very similar to what we already have. Now, as you're going through, you can click trace, and it's going to go through each of your x and y coordinates. It says plot 1, list 1, L2, and L1, which is exactly what we want. And you can see all the different points that are on there. And you have your scatter plot. So not only can we graph it by hand, but we can also graph it using the graphing calculator. Last thing I want to cover is any unusual features. So influential points and outliers. So when I talk about influential points and outliers, so let's say I have something like this, where I have something that's really strong, and then we're going to have like an outlier, and then we're also going to have an influential point. So if I have something like this, and we have our points increasing, we're looking at this guy, and we're increasing, and then I got this point all the way out here. This guy is called an influential point, meaning that it's already following the trend. However, it's just making that trend stronger. So this is a strong influence on the scatter plot. It's just making sure that it's following in line with all of my points, but it's something that is actually following the trend of the data. Versus an outlier, which is going to fall outside the pattern. So notice here how my x's increase, my y's are increasing. This is an influential point. It's a point that's out there but still following our trend. This guy, though, is going to be an outlier. Because here, as my x increased, my y didn't increase like it was supposed to and following the trend. So it lies and falls outside of the pattern. So influential points fall within the pattern that are far out there but still fall within the pattern. Outlier are ones that fall outside the pattern and that are really far out there. Then sometimes we have these gaps where I'm looking at another positive relationship here. So maybe I have something here and then it has like this gap and it comes back up. So something like this, where we have some gap in between our two different pieces. You also might have something with clusters, where we have a lot of points up here. So I'm going to look at a negative relationship now. And I have some points right here, and then we have some points over here. So these are just some unusual features that you might see, where we got some points here. So we got a cluster in the middle. We got a cluster over here. And we have a cluster up here of points. Still scatter plots because they're scattered points. So now you're going to be given a worksheet over all of this, and you're going to be practicing interpreting scatter plots and then making scatter plots and going through those, describing those features using your form, using your direction, and then also using your strength when you're describing those. And make sure you always put it in context of the problem.